want to start with a little bit of a review. These are two types of exponential functions. And if we were to draw these, what would your first steps be? What do you remember from the last lesson? What would your first step be? And what observations would you make straight away about these two functions? You can put your hand up, you can put it in the chat. I don't mind, but just thinking back, what do you observe about these two, and how would you start? If I said to you, sketch them, where would you start? Yes, the shape, intercausal. So is it increasing or is it decreasing? Exactly. So both of these, you would start with the shape. And let's call this sketch 1, or let's call it sketch, or let's call it H and F. In H, is it increasing or is it decreasing? Is h of x an increasing exponential function or a decreasing one? Yeah, it's increasing. And the reason we know that is because this value is greater than 1. All right, that's good. What about the function f? Is this an increasing or decreasing exponential function? Yeah, so this is going to be a decreasing, because in this case, a is 3.5. And so if a is greater than 0 but less than 1, we get this decreasing shape. If a is greater than 1, then we get the increasing shape. Awesome. Okay. And I'm sure you all remember step 2 and 3. Step 2 and 3 was finding the y-intercept and the x-intercept. What about step 4? What was step 4 about? Step 4 was about what's called the asymptote. Yes, it's like the no cross line. You may not cross here. All right, fantastic. So that is the asymptote. Now, I want you to do the working out for each of these two exponential functions, and I want you to draw them on separate axes, and I'm going to give you 3 or 4 minutes to do that. Okay, so go ahead. I want you to do the working out, and then I want you to draw them. And I'm going to give you some time. If you do have questions, you raise your hand and I'll assist and I'll guide. I want to see if you can draw these by yourself first. Cool. You can do it. Now I'm going to grab some water. Okay, so y-intercept we get so for the first one, I'm going to say that all the information should look like this. Probably the most tricky bit is finding the x-intercept. can you draw the graph based on this information for the first one? So I draw that first, and then I put a dot for my y-intercept. I put a dot for my x-intercept, and I think about what's the shape and does the shape fit? And the shape should fit like that. And this value should be -3, and this value should be 2, and it's called the function h. Give me a thumbs up if you are okay with sketching the first function. Give me a thumbs down if I lost you on sketching function h. Okay, so then we're going to move on to f. Now, f is a little bit tricky. I don't think you can find the x-intercept, but you can know that there is an x-intercept, and you can draw the graph even if you don't know what the x-intercept is. I'll give you a little cheat to figure it out if you really have to, but as long as you know it exists, you can still draw the graph. So Linda has asked, how do we find the asymptote? So the asymptote, Linda, in an exponential will always be a sort of q value at the end here. So you can see that -4, and this is -4. Now, in this one that we're doing over here, the asymptote, I can actually tell you, is just going to be -2. There's no mystery there. It's kind of like nice freebie marks. It's this bit over here. Because, yeah, so that's what the asymptote is going to be. So to find the y-intercept, so Nompilo says the y-intercept is -1. I agree. So that's the y-intercept. What about the x-intercept? Well, to find the x-intercept, I make y 0. And that gives me that equation. So I have to solve this exponential equation, and I can move the 2 across like last time. But this doesn't seem so easy. Why is this one not so easy, whereas the last one was easy? Can anybody share their thinking? Like, what makes this so much harder than the earlier one? No, so actually there is an x-intercept, Andile. So it's so funny here. There actually is an x-intercept, but it's the fact that it's a fraction, yeah. So if you think about this, there actually is a number that you can raise to 3/5 that will give you 2. But it's not it's a fractional base. If you imagine like this graph, right? I haven't drawn it exactly, but if you had a decreasing graph to start with, right? And then you moved it down by 2 units. So it went down by 2 units. It's definitely going to cross the x-axis. So there is an answer here. You just don't know what it is. So at this stage, all I would say is I'll show you at the end of this example a cheat way to get it. Not a cheat way, but in grade 12, you'll learn about something called logarithms that help you solve this. But for now, you know it exists, you just don't know what it is. So how do you draw it? So you draw it by doing the same steps as before. Okay, so you go, what is my asymptote? Okay, and where is it? It's just going to be y is -2. Now, what is the thing that we have? We know this thing. We know the y-intercept is at -1. And we also know the shape of the graph. So the shape of the graph is such that it goes like that. So I can label this -1. And we don't know what this value is, but that's fine. We can just show that it exists. And given in grade 11, at grade 11 level, you wouldn't have to fill it in. Now, I will show you how to get the answer just because it's interesting. If you want to find this exponent up here, there's a button on your calculator that looks like this. So it's log and it has a little square there and a square there. All you need to do to solve this exponential equation is you put the base, which in this case is 3/5, in the bottom block. And then in the other block, you put the 2. And using logarithms, that will give you the answer for x. So you can put this in your calculator and go log, and then put 3/5 as the base and put 2 as the sort of the square up here. And what answer do you get? Just out of curiosity, I'm showing you this now. Nompilo says minus 1.36. Does anybody else get that? I'm glad you got negative, because if I look at the drawing, you can kind of see that this is negative 1.36 here. Well, you can kind of see that it's negative. Yeah. But again, this is something you'll do in matric. But so in grade 11, you could have just said, look, I know an answer exists, therefore I'm going to leave that dot there. You don't need to understand the log part at this point. I was just showing it as an extra bonus, but in grade 12, you cover that. Okay. For now, you could have just left it out. So it could be, if you don't get minus 1.36, it's just because your calculator is in radians and not in degrees. So again, this extra bit, I'm not going to go over because it's not necessary for grade 11. All I was saying is that in the blue block, you couldn't solve this equation given grade 11 methods, but you know that a solution exists. And so you just draw the graph with it there, but not labeled. And then all I said is, if you want to get the solution, and you'll learn about this in grade 12, you can use the log button, where you just take whatever the base is and you write it in the bottom, and whatever the other number that was involved, you write here. And then if you press equals, you'll get the answer that you're looking for. But because it's not relevant for grade 11, really, I'm not going to go any further than that. Okay, now, that was the first part of the lesson. Here is the second part of the lesson. The second part of the lesson says, I want to find the equation of a parabola. I'm going to give you a parabola. In this case, the algebra says the following. It says f of x equals k to the x. I want to find out what the equation of f is, which really is just saying find the value of k. Who has an idea as to how we could find the equation of this exponential? Any ideas from the class? Yes, Kat, you would get marks. It's not wrong. It's just not in the syllabus in grade 11. Substitute using one of the coordinates. Exactly. Now, Zandisile, what I'm going to do is I'm going to choose B, because if I chose A, the 0 value would just give me it wouldn't be as helpful, whereas the B value has a value for x and y that helps me figure out k. So let's just make sure the x is 2. So I put a 2 here, and then over here on this side, I put a 9/4. So that's the substitution that Zandisile has recommended. But now I still want to get that k value by itself. Can anybody else suggest something to help me? How do I get to figure out what this k value is? Cody, how did you work that out? What was your thinking? So Cody said the answer is 3/2. Isa has said square root. Tomocho has said square root. Cody said, okay, you guys are getting this. So the reason that you do square root, you square root both sides, because square rooting is the opposite opposite operation to squaring. So it almost knocks out that, and you get left with the k on the side, and you get left with 3/2 on the side. And so, and the restriction is k is not allowed to be a negative number. So it can't be the negative 3/2. It has to be 3/2. And so we get, I'm going to say f of x equals 3/2 to the power of x. Okay, now what I want to do is I want to do a little transformation. I want you, so if k was negative, would it be a reflection? K is not allowed to be negative. So in this case, the k base, the value for k could only be between 0 and 1, in which case it would be decreasing. And in this case that we have, k is greater than 1. So k is greater than 1. That's why we see that the k graph here has an increasing shape. But we'll get to reflections in a moment. All right, now, if I said to you, I want to take the graph of f and I want to do a transformation on it, I want to know what happens to f if I shift it down by 2 units. So shift down by 2 units. What is the new equation g going to be? So I'm taking the original f and I'm shifting it down by 2 units. What is my new equation of the exponential going to be? So I'm shifting it down by 2 units. Think about it. So my new equation is going to be g of x, whatever the old one was, but then I have to take into account the fact that it went down by 2 units, so it's going to be -2. And what that graph would look like, it would probably look something like, oh, actually, let me try that again. So if that was 1 that shifted down, this would have to be -1, and it would look, let me even draw my asymptote. So if everything was shifting down, my asymptote would be at y is equal to -2 because that's shifted down. And the graph that I've drawn now would look something like that. And that would be g of x. Notice how the asymptote, which was 0, is now at -2 because it's shifted, everything is shifted down by 2 units. Where did I get the -2? Kabange, I just made it up. I wanted to know, kind of if you understood the idea of transformation. In fact, I like this question so much, I'm going to give you another one. What if I said to you, I want a new equation, let's call it h of x, and the way I get that is I have to shift it up by 1 unit. What would the new equation h of x be? I'm just playing around with transformations because I want you to get familiar with what's happening in these graphs. What would, so if h of x is, I'm just shifting up, and I'm shifting up f of x, yeah, so I should say where I'm going from. So I'm referring to f of x, and f of x was just this one, and so it would just become, h of x would become +1, will become 3/2 to the power of x plus 1. If you wanted to visualize it, you have to have your asymptote going along and it going up here. Give me a thumbs up if you followed everything so far. Give me a thumbs down if you're feeling a bit confused about these little transformations I was throwing in there. Okay. All right, well, let's move on to don't worry if you're feeling confused. We're going to still work on it. Let's do a little question like this. So this one says, the sketch graph represents f of x equals a to the x. Linda, there is a specific reason, yes. If you multiply a negative by a negative, it becomes positive. And if you multiply it by a negative again, it flip-flops. And you can't have a function which has dots or points all over the place like that aren't connected. So it's restricted to make the function continuous, is the very technical explanation. But basically, yes, there is a specific reason. All right, I want everyone to figure out, let's start with this. What are the coordinates of the point A looking at this exponential function? What is the coordinates of point A? Pop it in the chat. So how would you find A? A seems to be in line with where x is 0. So I think to find A, the point, you have to put a 0 here, which is 1. And so the point A is just going to be 0, 1. All right, so we've done that one. 2.2. How can we tell that little a is between 0 and 1 when we look at the graph? How can we tell that a is between 0 and 1? What gives it away for us? Yes, Linda, I like what I'm seeing. Who else has an idea? How do we know that this a value must be a fraction? What are we looking at? We see that it is a decreasing exponential graph. It's not taking off, it's coming in for landing. And so that's how we know that the value of a must be between 0 and 1. Okay, now 2.3. You need to find me the value of a by using the point B. And the point B is 3 and 1 over 27. I want you to find me the value of a and ultimately help me find the function f. So go ahead and do that. So I'm guessing using the point to sub it is probably a good idea. So that's the y. And that would be... Now, can somebody tell me, how do I solve this equation? Because I subbed it in, and that's all good, but now I need to get that a value by itself. What needs to happen to get the a to be by itself? Yes, okay, you guys are on fire today. So you have to cube root both sides. And when you do that, the a value should be equal to 1 over 3. This makes sense because, like we said earlier, you can see it's a decreasing exponential function. So f of x is equal to 1/3 to the power of x. So that is my function that I started with. Okay, now 2.4 is a bit different. 2.4 says, determine the equation of the graph obtained if f is reflected about the y-axis. Now, this goes back to something that's more general in transformations. And if you want to reflect over the x-axis, you do something. If you want to reflect over the y-axis, you do something else. Okay, so if you want to reflect over the y-axis, you change the sign in front of the x, or you make x. So I just say change x, or change the sign in front of x. If you want to reflect over the x-axis, you change the sign in front of y. Now, in this case, it's saying reflected over the y-axis, which means that we're looking at this bit over here. But let me actually show, before I even give you the answer to that, let me show you this working with points. So if I gave you the point over here, if I gave you the point 2 on the y-axis, if I say to you, you need to reflect this over the x-axis, all of you would tell me very quickly that the new point would be -2. So what have I done here to reflect over the x-axis? I changed my y from positive to negative. If I wanted to reflect a point over the y-axis, so let's say I had the point, over here 3, and I wanted to reflect over the y-axis, you'd have no problem telling me that the x value should be -3 on the side. So if you ever forget this rule, just think about the points inside of a thing. So for 2.4, if you reflected over the y-axis, you should change the sign. Sorry, if you reflected over the y-axis, you change in front of the x, you should get f of x equals 1/3 to the power of -x. Give me a thumbs up if that makes sense to you. Give me a thumbs down if I've lost you there. Okay, so you understand what I've done there. Then the last thing, and then we're going to take a break. What are the coordinates of the point of intersection of the two graphs? So we have, this is actually not f of x anymore. This is just the reflected one. We have the graph y equals 1/3 to the power of -x. We also have the original graph, which was that. What are the intersection points of these two graphs going to be? So we can see this here, right? Maybe we should look at the picture and maybe it can help us. We are reflecting over the y-axis. So the y-axis was this one here. If I look at this graph and I reflect it over this axis, the y-axis, I think it's going to look like that on that side and that on that side. Because you can see if I fold it across, it looks like that. What is my point of intersection going to be for the original graph and then its reflection over the y-axis? Yeah, it looks to me like I know what A is. I figured this out earlier on. I know A is 0, 1. And I can clearly see that would be 0, 1. Okay. Well, I think we're doing quite well. We've looked at a bit of revision of drawing exponential functions. We've looked at how exponential functions can be transformed. And now we've actually learned how to find the equations of exponential graphs. Linda, there is a way to calculate it, but in this case, it's much easier to visually just see it. And in these types of cases, yeah. I am doing units on intersection points later in the year, though. But we worked hard. In order to have a good second half of the lesson, we need to take a moment to just unwind and relax. So I encourage you to take a moment to just stand up, turn the cameras on if you haven't done so already. And what I want you to do is I just want you to start by just shaking out your arms a little bit, get nice and loose, pretend your arms are made of rubber, shake out your other arm, Check out both arms if you like, and you get a way of going, who knows, whatever floats your boat. Then you can sort of shake your legs in the same way, you put them out. Oh, I like this. There we go. You do this one, shake those hands, get some nice warmth. Oh, this feels nice. Or you can rub your hands together. There we go. All right. And then why don't we stretch out our arms a little bit? Stretch out there. Stretch out this one. Let's roll the shoulders back. Okay. And roll them forward. Oh, it feels nice. And then let's do some small circles. Going into bigger circles. And then let's go the opposite direction with the big circles into small circles. Okay, and then just a little bit of a twist, and hopefully you're feeling a bit looser and a bit more relaxed after taking your body for a spin. And then we're just going to do some skipping, some virtual skipping, just to get our heart rates up. And we can start in 3, 2, 1. Let's go. Okay, 10 more. And sit down. Cool. I hope that you got the benefit of your brain feeling like it had a break, and that your body feels a bit looser. We're going to just do a quick run at Maths 24. In case you're new, what we try and do is we try and make 24 using 4 of the numbers on a card. Any of the cards are available to you, but the easiest one is the yellow, the hardest, sorry, the easiest one is the red, the hardest is the yellow. And see if you can solve that problem. Pop your answer in the chat. Yeah. Who feels like they can get one of the cards? So Linda, let's see if I agree with Linda. Linda went straight for the hardest one. 5 times 3 plus 7 plus 2. Linda, I do believe 7, yeah. That is all yours. Well done. Who else could solve one of these cards? So notice how Linda used a 5, a 7, a 3, and a 2. Anybody else have a one that they think they can get? I'll give you a hint. You could go for the first one, 8 minus 5, to give you 3. That should help you along the way. So iPhone has said you go 8 minus 5 times 7 plus 1, which is great. So 3 times 8 and 24. So iPhone, that is yours. And Bongo Bossi has also said yellow, 7 minus 3 is 4. And times 3 times 2. Yes, that's a different way of doing it. That's great. Because 4 times 3 is 12, 12 times 2 is 24. And Londi has said, for the yellow, wait, 7 plus 3 times 2. Oh, wait, that's 25, hey, Londi? I think that is, yeah, but you're close, but not quite. So the only remaining one is blue. So I'll give you another sort of 30 seconds if anybody feels like they can do it. And then we're going to get on with the rest of the lesson.
I do have the answer for blue.
Oh, please, go ahead. Yes.
I actually stole it from someone from the last lesson. He posted the answer, but after we were done with it.
Okay, give it to me.
It was 9 minus 5 is 4, and then
Okay.
times 4 is 16 plus 8
So 9 minus 5 is 4, and then, yeah, and then,
times 4.
so you've got 4 times 4, oh, plus 8, because you've used the 9, the 5, the 4, and the 8. Yes, well done. Okay, we smashed the Maths 24 today. Well done, everyone. Cool. So let's get back to this stuff over here. Let me ask you about this question. Oh, Andile got 5 times 4 plus, oh, that's almost, yeah. All right. So let's go on to another type of question. This is slightly different. How is this one different to the last types of questions? So it says, find A and B if the following function is represented by y equals a times b to the x. So first of all, I want to know in the chat or over audio, what is different about this compared to the last one? And where would you start? So a is less than 0. Okay, but because you're on the right track. Where would you start? What's the difference is that it's reflecting about the x-axis, yes. So most of our graphs have been either like this or like this. This one is down here. So there's been a reflection. But what we really want to do is we need to figure out what A and B is. And I want to know, what strategies do you have for finding A and B? So this is increasing, but it's it is a reflection. But I want to see what strategies do you have for the algebra? Who has an idea? What do I need to do to get the party started here? So I need to find what A and B is. I have some information. It looks like an exponential graph because it has this x up here. Yeah. Looking, I said substitute a point. I'm going to substitute this point. And if I do that, I get minus 1 is A times B to the 0. Does that help me in any way? Does that help me? Who has, to the power of 0, I know that that's 1. So, but B is not going to be 1 actually. This whole thing is going to be 1, which means I get A times 1 is minus 1. And actually what that's telling me is that A is minus 1. So be careful there, because it doesn't tell me that B is 1. It actually tells me that A is minus 1 based on that point. So in my quest, I've now found out that this is what I know so far. Aha, Kavane's question is, how do you know what to sub in? So after doing this example, you will see that it is easier to start with it's generally preferable to start with the intercepts. The y-intercept will help you figure out the one straight away, and then use the other point second, is my tip. But you would have figured that out, because if you hadn't done it that way, you would have got stuck. But what's great about the intercept is this to the power of 0 blows anything out the water. And so all you get left with is this A over here. Now, what's B going to be? I suppose I should just sub in the same way I did last time, like minus 2 is this, and then there's B in a bracket, and I've got minus 1. Yes, because I've got my X over here. And I've got my Y over here. But now I'm a little bit stuck again, because I need to find what B is. Okay, so Andile said divide by -1. So we get -2 over -1 is b to the -1, which actually means I get down to this. So I'm getting closer. What do I do about that? Okay, so that's sneaky. Okay, so Kat, you don't have to go to logs at this stage. I was thinking, isn't there a law? Yes. So I was thinking we could write this as 2 equals 1 over b. And then I can move the b to the other side. So I get 2b equals 1. And then if I bring the 2 back, I get b is equal to a half. And so what is the final equation of rule? It's going to be -1 or just a minus a half to the power of x. And that is going to be the equation of this graph that we've just dealt with. Now, what I want to point out is that it was important to first sub in the y-intercept point, and then only second do the other point. That seemed to make life a bit easier. So we want to reuse that technique if you see it again. Give me a thumbs up if you feel like you followed my arguments. Give me a thumbs down if you feel a bit lost. Okay. Linda, it's generally a good idea because if you yoke the other way around, you have two unknowns. You have both A and B being unknown, and that makes life more difficult now. Okay, well, let's do this question. So here is a question for 5 marks. And I want you to try and do this kind of by yourself. I will answer questions if people raise their hand or have a question. But see if you can do this 5-mark question over here. So the first question is, here's an exponential function. Find the value of a, which is this thing. See if you can do that. So what is the value, or determine the value of little a there? Aha. Okay, Michaela and Dile got some answers. Let's see if I agree with you. So I know I need to sub this point in. So I get 8 is a to the -3. But that is a negative power, so I'm going to do that. It's messy having it as a fraction. So I'm going to bring it across and I get 8. A to the 3 is 1. And then I'm going to get 8, so 1 over 8. And what do I need to do there? It seems like to undo a cube, I need to cube root both sides. And so Bocheng, I agree with you, it's a cube root, and the cube root of 1 over 8 is a half. So a is a half. Okay, what about the coordinates of p? What are the coordinates? Write down the coordinates of p. So what is the value over here going to be? Well, it's kind of, that's actually not so bad because it's x is 0. And so if I go, it doesn't really matter what the a value is because it's going to be 1 and the coordinate is just going to be 0, 1. Yeah, that's it. So with exponential graphs, the asymptotes, the intercepts are fairly predictable because of the power of 0. Okay, what about g of x? So it says, if g of x is the reflection of f of x in the x-axis, determine the equation of g of x. So you need a bit more time for this. You know that f of x is a half to the power of x. Now what it's saying is, look, there's another function called g of x, and it's the reflection of the f of x in the x-axis. So if I reflect it over the x-axis, I suppose there is the x-axis. Now, what is the algebra going to look like for g of x? That's the question. It might even be easier to write the g of x in the form y equals, and then we can always do, you can just put a g there. So if you reflect over the x-axis, the rule that I was remembering was that you change the sign in front of the opposite variable. So there'd be a negative y equals, what was the f of x was still a half to the power of x. But we don't leave the negative y on this side. We bring the negative y to the other side, and we get y is equal to negative a half to the power of x. Now, the important thing is that the x up here should be positive. There's no negatives up here. If I change the negative there, I'm reflecting over the y-axis, and I want to reflect over the x-axis. And to reflect over the x-axis, the negative had to either be here, or I can move it across to the side, which is generally what we do. So that was a little bit more interesting because of the reflection. Okay, 4.1.4. What would the equation of f of x become if the x-axis is moved down? If the x-axis... Okay, no, I'm going to leave that question because that's a little bit ambiguous. So I'm going to leave that one out because it's not talking about moving the graph. It's talking about moving the axes, which is a different type of question. So we'll leave that for now. I'll re-explain 4.1.3. If g of x is a reflection of f of x in the x-axis. Okay, so to re-explain 4.1.3, if I want to reflect in the x-axis, right? All I need to do is change the sign in front of my y, or change the sign in front of my other variable. So what I did was I just said, look, the original equation was y equals a half to the power of x. That was the function f. In order to get g, I needed to reflect over the x-axis. So I changed the sign in front of the y. But when we write functions, we often write it with the y by itself. So we could rewrite this in this way. Just give me a thumbs up if you understand what I did with 4.1.3. Give me a thumbs down if I'm leaving you a bit confused at this stage. Okay, awesome. There's a couple of students who are feeling a bit confused. So just remember that rule. If you reflect over the x-axis, you change the sign in front of the y. If you reflect over the y-axis, you change the sign in front of the x. And that will serve you well. Okay, let us. Can we sneak in? Let's try and do this one. Maybe this will be the last one we do. Okay, there's actually this is actually a good one because it kind of breaks some of the rules from earlier on. So it says here, there is a positive exponential graph, y equals a to the x plus 2 plus q, passing through the points 0, 2, and -2, -1. Now, before we even do this, because this is going to be our sort of last question, what are the two transformations that have happened to the simple exponential graph y is equal to a to the x? There's two things that have been changed. I want to know what are those two things that have changed just in terms of your observation of functions. And you can raise your hand if you like, or you can put it in the chat, but I want to know what things are happening to a basic. So this thing over here, this x plus 2, is actually a horizontal shift. It shifts 2 units to the left, and the q is a vertical shift. It's a shift upwards. So that's important. So this is the x plus 2 shifts 2 units to the left, and the plus q shifts it upwards or downwards, depending on what q is. Now, in order to solve this problem, you need to find a value for a, and you also need to find a value for q. And actually, which points you choose will help you, but there's not a, you actually have to use a bit of trial and error. So I'm going to let you try this out and see if you can find me an a and a q value. Which point do you think would be helpful when you first start this? Yeah. Might be interesting. Which point do you think would knock something out, not knock it out? That's the hint I'll give you. Tell me in the chat which point do you think we should go with first. So Futi, not to can sort of, well, you're not actually sure if it's the y-intercept. Well, actually, you well, x is 0, but in this case, it may not. No, yeah, it would be the. Would it be? I don't necessarily think you can conclude that. I think going with 0, 2. Let's go with it, because most people have said that they would go with that. But let's have a look. So if I put 0, 2, I get 2 equals a. I put a 0 there, but now I've got a plus q, which means I've got 2 is equal to a squared plus q. The problem with that is I have two unknowns. I have an a and I have a q, and they're both unknown. So it feels like, even though in the last one it was a good step, it feels like now it gets me nowhere. So what I have to do is I have to reverse and try and use that point. Let us know in the chat if that helps you. Tato has said, if you put the other point in, you can get the exponent to be 0. And I see where you're going with that, Tato. So let's have a quick little look back here and see if. So it seems to be the main idea is to get the power to be 0. So if I put a minus there for this, and there was a plus 2, I do agree that it gets to 0. And then this can't be minus 2 anymore. This has to be minus 1 for that. And so we get minus 1 is a to the 0 plus q. What is q going to be equal to? Because that does make sense to me. But what is q going to be equal to? Well, I think this is 1. And so if I bring that across, I'm going to get q is minus 2. So this is minus 2 equals q. Okay, that's good news, because now I know that this is minus 2. So I've just got to figure out what a is. But what I found out is this graph has been shifted down by 2 units. So that's the information, the first bit. Now I need to find out what A is. What's A going to be? I guess I have to use the other point. The other point was 0, 2. And if I sub that in, what am I going to get? So I put a 2 where my y is. And I put a 0 here. Plus 2 minus 2. So there's quite a lot going on. If I bring this minus 2 to this side, I get 4 equals a squared. And then if I square root both sides, I should get a is 2. Aha. So the final equation, after all that hard work, is going to be y is equal to 2 to the power of x plus 2 minus 2. And in terms of transformations, what happened was this graph was shifted 2 units to the left and also shifted 2 units down. And that's what would have happened. Okay. So guys and girls, that is our lesson for today on exponential functions. We really need to work hard on finding the equations there. You just put the link to the quiz, Simone, in the chat. And next week, we are going to be talking about trig functions, which are periodic or repetitive functions. Could I draw the graph, Andina? I could. What I would do is I would go through my 4-step process. So I don't know if I'm the whole time now, but if you think about the basic shape of this graph, the basic shape comes from this, essentially it's going to be this one. What would my y-intercept would be y equals 2 to the 0, 2. So I get 4 minus 2, which is 2. So the y-intercept would be at 2. And then to find the x-intercept, I would have to make y0. So we get 2. And then my asymptote would be at minus 2. That's it. Yep. So there's your information, and that's how you would draw it. Yeah.